What is the best way to organize your workflow when you're writing a paper that includes some sort of data analysis in it? You may be tempted to just write everything inside an R markdown document, so you can have the main text there, and every once in a while you will have an R chunk. You can also have, if you do the data analysis in Python, you could have a Python chunk, and you could put the data analysis inside these code chunks inside your main paper. So what is wrong with this kind of workflow? There are two main reasons why this is not a very good idea. One is that it's a good practice to separate the data analysis from writing the paper. So if you put the data analysis inside your main paper, you're always going to be tempted to mess around with the data analysis rather than just focus on writing the paper. Right? So it's going to interfere with the actual work in writing the paper. Now, the second reason is that some parts of the data analysis will take some time, right? It may take a long time, and long doesn't even mean hours. It could just be 10 seconds. Usually, you are going to knit the document throughout your work many times. So if these data chunks take a long time, it's going to slow you down a lot. For this reason, it's a good idea to separate the data analysis from writing the paper. Right? You don't want to just redundantly do the same kind of analysis over and over again. So you want the data analysis to be done as few times as possible, and that analysis will give some outputs, which will be tables and figures, and then you will just include the tables and figures in your paper. So you don't want to just have one single R markdown document. This also has some additional advantages if you want to come back to a project after a longer period of time, right? You may not remember exactly what you've done. So if you are going to have a project with multiple files, it's good to have a good organization of that project so you can get back to it and quickly see what you've done in the past. Similarly, if you work with others, you want them to very quickly be able to assess your work and see what you have done. And this becomes truly a necessity if you have larger projects. And by larger, I don't necessarily mean like a book. It could just be a single paper, but a single paper could use different methods. It could have use different data sets and combine them in different ways. So even something like a single paper could get pretty big and could have many different parts of the data analysis. So you may want to keep them separate and very easy to recognize and to see what exactly each part is doing. Okay, so the basic workflow is, on one hand you have the data analysis, and on the other hand you have your paper. So the data analysis, the best way is to just put it in regular scripts rather than in R markdown files. So you will have some R scripts which will generate figures and tables, and then those figures and tables you will include in your markdown file, which will be the paper itself. So you can have the main paper, you can write it as a simple markdown that doesn't have any kind of R chunks, or you can do something like I've done here, where you have some chunks of code in the main document, but these chunks of code are going to be very minimal. They're not going to actually do the analysis itself. So you'll see here, there's one line here that just loads a bunch of objects that have been created with a script before that. So the data analysis created these objects, and now my paper is just picking up the objects that were already created. There's very little time involved because the objects are already created. The R markdown file doesn't recreate them. A general workflow would be something like this. So you have some raw data that may not be properly formatted for what exactly you want to do. So for example, it could be that the raw data includes a ton of data, right? Many variables that you don't actually need. For example, you could get data from the World Bank, right? So those are thousands upon thousands of variables. You will want to select only the variables that you want. A second type of situation is where you have the raw data, but you need some type of different data that you can calculate from the raw data. For example, you could create categories that are not existing in the raw data, but you could derive them from the raw data, right? So for example, you could do a cluster analysis on the raw data, and that will create categories that then you can use in your analysis later. Right, so this would be examples where you are using the raw data to create variables that you will then find useful. It could also be that the raw data coded in a way that's not the most intuitive, right? So sometimes the data is reverse coded, right? So intuitively, a larger number means something, but the data is coded the other way around. So you may want to change that to make it more intuitive. Another step here with which you have to take more care is that you may want to impute some of the data. For example, you could have data only every once in 5 years, but you want to impute the data for every single year. Right? Obviously, this is a lot more problematic, so you want this to be very clear when you do this right in your scripts, and of course you want to mention this when you write the paper, that some of the data you've used is actually imputed rather than actually measured. Okay, so you will have some script that takes you from the raw data to the clean data that is just very useful for your specific analysis. Then with this clean data, you will have, you may have a different script that actually does the analysis, right? So for example, you could do some regressions, right, based on the variables you have selected. And this script will generate the figures and tables that then you want to incorporate in your paper. Okay, and then this can be rendered as a PDF and you can submit it. Right? You can also render it as a Microsoft Word. Right? So this is very easy to choose whatever format is best for whoever wants the paper submitted. Okay, so if this is the typical workflow, how should you organize your project? Right? So your project is going to have more than one file. So how should you put these files together in a way that's most intuitive and easiest to get back to it, right? So usually you're going to have your project is going to be one folder that's going to include everything. So inside this folder you will have a certain structure. So I would suggest something like this. So on one hand you want the raw data to be separate from the other. Right? So you'll have a folder with the raw data and you put the raw data in there. Sometimes you don't need this because you may say download the raw data, for example, from the World Bank or from other APIs. Right? So you may not have the raw data downloaded here. But if you do, right, it's a good idea to put it in a separate folder. Then separately you'll have the data that you're actually using for your analysis. Right, so this could be the data that you have generated with the script that did the selection of the data. Maybe you have imputed some of the data and so on. Now, aside from this, you will want to have a folder with your scripts, okay, or code, something like that. So you're going to put all your R scripts inside this folder. Right, so this will keep things organized. So now the scripts, right, the first ones are just going to take data, the raw data, and create the data that's actually for the analysis. Something else that the scripts are going to do in this stage, they are going to create figures and tables. So you want to store those figures and tables in another folder. So you may have separate folders, one for figures, one for tables, or you can just have a single folder for the R objects that you have created, and this could be both figures and tables. So now, aside from this, now you want to have the paper that you're writing in Markdown or R Markdown. So you could just put that in here, not in a particular folder, so that will make it easier to just grab the objects from the objects folder. Okay, so if you are writing in R Markdown, the easiest would be to organize it something like this. So you will have your paper in R markdown, and when you render that, it's going to generate the PDF in the same folder here, right? And this gives a pretty good organization of everything. So now, how do you generate the objects in the first place, right? And how do you include them in your R markdown? So you generate them in your scripts in the following way. In case of figures, you will just have some ggplot figure that is going to create an object, and you save that object, you give it whatever name you want to give it, right? It's usually a bad idea to just call it figure 1, figure 2. You want to give it a descriptive name of what exactly the figure represents. And the same thing you can do with tables, right? You'll have a data frame or a table, and you save that object, you give it a name, whatever you want. And then at the end of the script, you will use the command save, and you're going to save it in this in a file that will have the extension rdata. You could call it whatever you want. So because you are doing this from inside the scripts folder, you have to be careful to first go outside of the scripts folder and then go inside of the objects folder, and there you are going to put your objects file. If you have multiple scripts, right, each of them will generate different rdata files, right? So you can have several of these rdata files, right? So one of these rdata files could include several figures and several tables. You don't have to split the figures and tables when you do the analysis. You can just put them together in the same object. But again, you may have different scripts, each of them doing a different type of analysis, and each of these scripts could generate multiple figures and tables. Okay, so once you have these objects, rdata objects, in the objects folder, you can include them in your main paper by just loading the objects, right? So now the main paper is going to be right here in your project folder, so you can just load it from objects and your object, the name of the object, whatever name you gave it, right? So if you have multiple scripts that have created multiple objects, you will have multiple of these load commands, right? So what the load command will do is going to create, in the context of the R markdown file, all the objects that the analysis has produced, right? So it's not going to redo the analysis, right? So this is why this is going to work much faster. Okay, so if you include the analysis in your R, the R chunks, right, that's going to take a long time. But if you save the objects and then load them, then that's going to work way faster. Right, so this is why this is a much better workflow. So let me give you an example of how this worked in practice with a real-world example. So this is a paper that is co-authored. So this involved working together on the script, right? So this is part of the reason why you want to have a properly organized script. So this is how the project looks like. So there's some code here, and there are 2 R files. Basically, this is not necessarily organized the best way, because pretty much all the analysis is done in one single file, and you'll see it's a very long file. But that could work, but you could also split it if you want in several different files. Then we have here the manuscript, the RMD manuscript that you see here, right? You see it's a very long manuscript, and it has some R chunks, right? This is just setting up, say, how the figures are going to look, and it's loading all the objects that have been created before, right? So those objects are created from this R script, right? So you will see at the end of the R script, it's saving all those tables and figures, right, in this file called objects R data. Okay, so throughout the script, okay, there are different steps in the analysis. So here are all put in a single script. Again, it may be a good idea to split this into multiple scripts, or whatever works better. Okay, so here's an example. This part of code is creating a statistics table. Okay, so it's doing some analysis here, and it's saving that analysis in this object, table Fraser stats. Okay, and this object, it's saved here. Where is it? Here. And in the main text, we have the table stats object, right, which has been loaded at the beginning, and now is doing a little bit of style on the table, so it looks better. So that's all that is done in the RMD file, right? So it's loading the objects, and then it's just printing the objects inside the paper. Here you see another of these objects. This is a figure. So again, the RMD file is just loading the objects and showing them here. So in this case, okay, there is a caption to that figure, and you see here there is a label to that figure. So that label allows us to reference the table in the main text. Okay, so this reference here, this label that we have added, is then referenced in the text with the ref. Right, so in the main PDF, this will just show up as a reference to the number of that figure, whatever it is. Okay, so this type of work so far, it included an R script that generated all these objects, figures and tables, and the paper itself, which loaded the objects from the objects folder. Okay, now the paper itself has more than just the calculated figures and tables. So it includes some tables that are just markdown tables, right? So these are not generated by the R script. Those were just included as R markdown tables. Another example is that some of the figures are also not generated, but they have been drawn. Okay, so you see here there is a folder called figures, right, which is different than the objects folder. Right, these objects are created by the scripts, but then there's a figures folder, which are a bunch of figures that we have created by hand. Okay, so this is an example of a figure that is then included in the R markdown file. Right, and these have been created with the draw.io, which looks like this. Okay, so it's a pretty good program for generating figures, very quickly. And with this program, you can export the figures, right, either as an SVG file or as a PDF. Right, it allows infinite zooming on the figures, and they will still look good. But you could also just export it as PNG files. Okay, so these figures here have been created with this program, then exported as PDFs, and then they are included in the main text. Okay, so they are included simply with the regular markdown syntax, right? Which this will be the caption of the figure. This is the label with attached to the figure, so we can reference the figure in the paper, and this is just the path towards that figure. Okay, so it's in the folder figure. It's in the folder figures and the name of the PDF. So you can have some of the figures generated with the R code, or you can have some of the figures created with some other program. So some of the additional documents here, right? This was a paper it's submitted to a journal. So when you submit a paper to a journal, you don't want the name to be there. So that's why there is a separate R markdown file that just removes the name. And some of the journals, they don't want the figures and tables to be included inside the text. right? So then you want to separate the figures and you want to separate the tables, right? So this is what these two our markdown files are doing. So what's happening here is basically there's a tables file that just has the tables, right? Some of these tables are the markdown tables and some are the ones produced with the analysis, and the same with figures, right? So these are all the figures that some of them are drawn with draw.io, some of them are the result of the data analysis. The submission then included 3 separate files, one the manuscript without authors and without tables and figures, and one file with the figures and another file with the tables. Okay, so this workflow depended on saving the figures and tables as our objects. But you may not want to do this. You may want to save the figures and folders as, for example, figures as SVG files and the tables as LaTeX tables. So can you do that? Yes, you can. Okay, so suppose you want to just write your paper as a simple markdown rather than as an RMD file, right? So instead of having those R chunks in your paper, you don't want to have any of that. You just want to be a plain markdown file, right? So for example, you may not like writing the paper in RStudio. You may write it, say, in Visual Studio Code or in other program where it's easier to write markdown, right? So you may want then to completely separate the analysis from the markdown itself. So inside your scripts, you're going to create the figures with ggplot just as before, but instead of saving that as an object with an object name and saving it with save as an R data file, you can just use ggsave and to save each specific figure as an SVG file or as a PNG file, whatever you want. So with the ggsave, you can also specify just how big the figure is. You can specify the resolution and so on. So you can basically work inside your script to have the figures look exactly the way you want them to look. And then you will just include the figures in your markdown, just as I included those figures created by hand in draw.io. What about the tables? So the tables, you will want to save them as a LaTeX table. So you can do this in multiple ways. So one way is to use the xtable package in R. So if you use the function print.xtable, you can specify that you want a LaTeX table. You can give it a caption. You can also put the label there, and you are just going to specify what file, the name of the file, right? So for example, you could have here a folder called tables and another folder called figs. So this one, we saved it in figs. So now we want the tables. We want to save the tables all inside this folder. So you could do this with print xtable, and you just specify the path towards the LaTeX table. Right? So this is just going to create a LaTeX table from your data frame. If you're doing regression analysis, it's actually even easier. You can use Stargazer and have the option out, which will just do the same thing as file here, and it will save the regression table as a LaTeX regression table. Stargazer can also do summary statistics, right? So you could use that, and again, you can save it as a LaTeX table. So once you've done that, inside your paper, right, which now is just going to be a simple markdown, you can include all the figures with the regular markdown syntax, right, for figures, which this will be the caption of the figure. This will create automatic numbering for the figures, and this will just be the path towards the figure you saved with ggsave. And in case of tables, Inside Markdown, you can include pretty much any kind of LaTeX code you want. So this is LaTeX code here. It just says that, hey, I want in here to have this LaTeX code inside your Markdown. Right? So basically, this is just going to include the table that you've created before inside your Markdown file. Right? So this could be, depending on your preference, this could be easier or harder than just using our objects, right? So in the example I showed you, we just used our objects, right? We created them with the R script, and then we saved them with save, right? Instead of doing this, we could have just saved each figure inside a figures folder and each table inside a tables folder. And then instead of having an R markdown file, here we could have had a simple markdown, and we could have just used the regular markdown syntax and just LaTeX syntax for including text tables. So all in all, this is the basic workflow, right? So you want to keep the data analysis separated from the writing of the paper, and basically the data analysis is going to create figures and tables, and it's your choice. How do you want to save those figures and tables? You can either save them as R objects and then load the R objects in an R markdown file, or you can save those figures as PNGs or SVGs and the tables as LaTeX tables, and then include them in a simple markdown paper. Once you have the markdown paper, right, if you're writing it in RStudio, you can just knit it into a PDF or a Word file, or if you are just writing in VS Code, there's a Pandoc extension that will just do exactly the same thing. And if you're using some other programs, you can basically just use the Pandoc program, right? So this will you will have your paper here as input, and you're just going to say that your output is going to be a PDF file, and that's just going to create your PDF. Okay? And the same, if you put here an extension, docx is going to create the Microsoft Word document. Right, so this is basically, you're not stuck to RStudio if you don't like to write the paper in RStudio itself. You can just write it in whatever is your preferred program for writing in Markdown.